All right, welcome back, everybody. We are moving into Project 10, Zoetrope of our Arduino Starter Kit. And in this one, we are really looking at a motor, kind of spinning clockwise, counterclockwise. However, there is a new component on the board that I want to pay particular attention to here as we're kind of walking through the code. It's called the H bridge. It's just a circuit, but we'll talk more about it when we walk through the board. For now, as usual, this first video is going to be walking us through the code. So let's go ahead and start there, and we'll talk about where some of our output and input pins are specifically related towards the H bridge, which again is a new chip that we're going to be seeing for the first time in this project. So with that said, we normally start off with our setup and loop. I just haven't included them in this visual because we're going to be paying attention to the variables first, right? So the initial variable that we want to pay attention to is our analog pin, in this case A0, and all we're going to be doing here is reading in from our potentiometer. The more we twist it, the faster or slower the motor is going to turn. The next thing that we're going to look at here is the enable pin for pin 9. And this is the first pin that I want to talk about because it directly relates to the H bridge that we're going to be looking at. And pin 9 really is telling the H bridge to go ahead and enable itself, meaning go ahead and start taking instructions, start processing input, right? In this case, our input is voltage, but this is the enable pin that tells the H bridge to go ahead and accept everything that it's getting as actual instructions rather than just kind of dumping it out to ground, okay? Now, next, what we're going to be looking at is our control pins. In this case, specifically, we're looking at our control pins 2 and 3. And the way that these two pins work is when pin 1, or our control pin 1 variable, which in our case is the Arduino pin 2, when that is producing output, it's going to go into the 7th pin of our H bridge. And from there, we'll see that control pin 2 variable, which is pin 3, excuse me, which is pin 3 on our Arduino board, that pin is going to go out to pin 2 on our H bridge. And so we have our pin 2 on our Arduino board going out to pin 7 of our H bridge, and we have pin 3 of our Arduino board going out to pin 2 of our H bridge. And the way that these two interact, it's really the control for the direction of the actual motor, right? So these two, control pin 1 and control pin 2, are going to work together to determine which direction to spin or rotate our motor, okay? And pay attention a little bit to the book, and again, obviously in the board walkthrough that we'll do here in the next video, just to understand a little bit more about where the output from our Arduino board's 2 and 3 pins are plugged into the H bridge. And again, our 2 pin on Arduino goes to pin 7 of our H bridge, and our pin 3 of Arduino will go to pin 2 of the H bridge. And it will make more sense when you look at it in the next video, and it shows it pretty well in the book. Next, we are looking at our directional as well as our on-off switches, and these are just the buttons. These are the buttons at the top of the board, right? The very, very top switch is going to go to pin 5, and so that's going to determine whether or not we turn it on or off completely. And the second switch a little bit further or a little bit closer to the potentiometer in the diagram, that's going to pin 4, and that's going to determine which direction we want the actual motor to rotate in. Again, clockwise or counterclockwise. All right, and we can see here those are just the pins that we're going to be configuring for output. I'm sorry, for input. Now, the on-off switch, we're basically saving state here. What was the last command we got for on-off, and what was the last and what's the current on-off state, right? And so that way we can determine if it's different than the last time we got a command, go ahead and change it. And that's what these two variables are going to be used for later on. And kind of sticking to the same principle. What was the last time we got a direction? Is that direction clockwise or counterclockwise? And if it's different, go ahead and save it. So next time we iterate through the loop, we have a clean starting point to reorientate the motor on whichever direction we're going to spin it. And then here, finally, we're looking at the motor direction. And there's a couple things for the motor to need to pay attention to. One, what's the speed, right? The more we turn the potentiometer, the faster it spins. Is it even turned on or off to even begin with? And that's what we're looking at with the enabled variable. And then which direction is it turning, right? Or rotating? Is it clockwise or counterclockwise? And so that's all the variables that we're going to be using in this program. Again, the state variables, they might seem a little confusing, but realistically, they're just there to say, hey, what was the last command you told me? Was it on or off? If it's not different, don't do anything. If it is different, go ahead and change the state. On or off, clockwise, counterclockwise, whatever it may be, right? So that's all that we're looking at there. And next, what we're going to do is we're going to set up our pins that we're going to be communicating with the breadboard between the Arduino board, right? And so our enable pin, which is basically telling the H bridge to turn itself on or off, we're going to set that to an output, right? And our enable pin is pin 9. Our control pin 1, which is pin 2 on our Arduino board, we're going to set that up for writing as well, because we want to tell the H bridge when to turn on or off and which direction, really. And we looked at control pin 1 and control pin 2 earlier. They work in tandem together. Those are the two pins that are going to be determining which direction the motor rotates in. So again, control pin 1 is pin 2 on our Arduino board, and control pin 2 is our pin 3 on our Arduino board. And from our Arduino board's pin 2, it goes out to pin 7 on the H bridge, and pin 3 on our Arduino board goes out to pin 2 on our H bridge, right? And so again, those two are the main controllers as to what direction the motor will rotate. Now from there, we need to be able to read in the switches, whether or not they're pressed, right? So we need those as inputs. Did you turn it off, or did you press the middle switch to reverse directions, right? And so those have to be input pins that we're going to be reading from. And then finally, we're going to set up our enable pin, which in this case is pin 9. And so we're going to set that to low initially. And we're setting that to low basically so we don't, as soon as the board starts up, we don't start rotating the motor until you hit the button, and then you turn it on, right? So we're hitting that enable pin to low again, just so we don't start up and the motor goes crazy at full blast. And so that's the only reason we're setting that to 0 or low. And with that, we're pretty much ready for taking a deep dive into the loop function. And there's not too terribly much in here that's going to be new. I think understanding the circuitry is what's going to be the most important here. But as far as the code is concerned, pretty straightforward. The first thing that we're going to do is we are going to read in on our digital input whether or not the switch that turns the motor on or off, we want to read that in first, right? And if you remember, that switch is pin 5, right? So the motor, or the button that goes to pin 5 tells our board whether or not to turn the motor on at all or not. And so we look at that switch state, right? And we're pretty much using this as binary. Any value that's not 0, it kind of says turn it on. And then the next one is the state that we're going to read in from our direction switch. And this is that middle switch that goes to pin 4. And this is just going to determine whether or not we rotate clockwise or counterclockwise. Now, we are going to then read in from our potentiometer. And if you remember, our potentiometer, our pot pin, right, our potentiometer pin, which is A0, is an analog pin. So we can get a value from 0 to 1023. But we're going to want to use that value, which is the motor speed. We're going to want to write that out to the H bridge, so we know whether it's going to be slow or fast. And so again, we have that divided by 4, because we know when we write out to a digital pin, we can only have a minimum value of 0 and a maximum of 225 or 255. And so that's why we have that divided by 4. So again, these most recent 2 lines, we're going to read in the switch for direction, and we're going to read in the analog value for our potentiometer. Do we have it cranked up or turned all the way down? More or less, that's what that is. Now here, what we're going to look at is we're going to say if the on-off state is different than the previous on-off state, then we're going to cycle it. And all this means is if it was 1, now it's going to be a 0. If it was a 0, now it's going to be a 1. That's pretty much all that we're looking at here. Now, this second conditional on the state equals high, meaning we're really only going to do this if the button is pressed. If the button's not pressed, we don't care. We're going to leave the on-off switch state as it was previously, right? Otherwise, you'd have to hold the switch down to keep it turned on, and that just doesn't make sense, right? So once you tap that on-off switch, that top one, we say, okay, is it different than what it was previously? And we're going to say, okay, yes, it was. And we're going to say, is that high, right? Because you turn it on, you press it, we want to go ahead and enable the motor. And what's going to happen here is the next time the loop comes through, then it's going to be low. And so the previous state is going to be different, right? So it was high, now it's low, but we don't really care. Again, this is so we don't have to hold the button down. And so that's why we look at, if it's high, go ahead and change the state. And that's all there, that's it, right? Bring it in. If the user has pressed the button, turn the motor on or off, and wait until the next time they press the button to turn the motor on or off again. That's it. And so what we're going to do next is look at the direction. And it's the exact same principle. When the user presses this middle button, we're going to get a change from the last time that this button was, it was in a up state, right? Nobody was pressing the button. And we're going to look at that and we're going to say, hey, the value is different. So let's go ahead and look. Is the value different because somebody pressed the button? Meaning, is this coming in on a high voltage? The answer will be yes when you press the button. And it just changes the motor direction. The next time again, and then you release the button. And the next time it comes in this loop, it'll say, hey, is the direction state different than it was previously? And the answer will be yes. But the difference is that there's nobody pressing the button. So again, we don't really care, right? We're going to keep moving in one direction until you hit the button. And that's, again, these two are the same exact concepts. Now what we're looking at here is we need to determine what direction we're going in. Is the motor direction that we read in from the, is the motor direction that we calculated up from that middle button being pressed, is that a 1, meaning clockwise, or is it a 0 being counter, and really is it 1 or anything else? If it's anything else, go counterclockwise. If it's 1, go ahead and go counter or clockwise. And so you'll see here that we have our control pin 1 and 2, and our control pin 1 is really our Arduino boards 2, and our control pin 2 is really our Arduino board 3. And remember how we spoke about how those two work together in tandem with the H-bridge? And so you can see here, if we turn one on high and one on low, we get one direction. If we turn, reverse that, we get the opposite direction. And all we're looking at is the motor direction, right? Has it changed? And again, it only changes when you hit the button. So again, we're just leveraging the data that we've already pulled in. Now there's a couple more lines of code in here that we need to pay attention to. And here we need to write out to the enable pin, which is our 9 pin. And from our 9 pin, you'll notice that it goes into the enable, right? And so our 9 pin, which is determining whether or not it's enabled, has an analog write, and to that it's going to also provide the speed of the motor. And this is why our potentiometer went from slow to fast, or you'll see it in the next video. But this is exactly what it's doing, is that analog write, that motor speed is a variation. Obviously if it's all the way down, it's just going to be 0. But the only way that we get any speed out of it is if the motor is enabled, right? We get the motor enabled from our earlier conditionals as to whether or not that top pin for top switch was turned on or off, right? And so if it is on, it's going to rotate the motor at a given speed. We already determined which direction we're going to rotate the motor based off the control pins 1 and 2, but the enable pin is what gives it its speed, how fast it's going to go, and we get that from the potentiometer. So here, the only thing that we're doing is just setting our previous states to our current state, right? And that way we make certain that the next time we come back into this loop, all our conditionals still line up, right? If we didn't do these last 2 lines, the logic would get very, very out of whack, because technically, like if you hit a button, we wouldn't have saved that state, so the conditionals wouldn't work. So these last 2 really are just setting up our variables, so the next time that we come into the loop, all our conditionals make sense, and we can continue to run the application. So that's really about it from the coding perspective. I think it'll make more sense as we look at the next video for the board walkthrough on this project. Again, with the H-bridge, it can kind of throw you off a little bit, but it's just an opportunity that there's a lot of circuitry in that H-bridge that we don't have to wire up ourselves. And that's very convenient. So we will see you in the next video for that board walkthrough. And it's going to be a good one that you're going to want to experiment with a little bit. So looking forward to seeing you in the next video. Take care, everybody.